Hi, welcome to our another video lesson. In this class we are going to see exponential distribution under continuous distributions. First, let us see the definition for exponential distribution. Random variable or continuous random variable capital X is said to follow an exponential distribution with parameter lambda greater than 0 if its probability density function is given by f of x equal to lambda into e power minus lambda x. So here the probability density function for exponential distribution is f of x equal to lambda into e power minus lambda x. Lambda is considered to be parameter here, and except x greater than 0th interval f of x is 0. F of x does not take any value. That is its definition for exponential distribution. And next we shall see how to find out moment generating function for exponential distribution. As usual, what is formula for to find MGF of a random variable? That is nothing but f of mx of t equal to integral minus infinity to plus infinity e power tx into f of x dx. So this is general formula. This is general formula to find out moment generating function for any random variable. But now, as we have taken x follows exponential distribution, its probability density function is lambda into e power minus lambda x. So simply substitute f of x equal to lambda into e power minus lambda x here, then we can get integral 0 to infinity e power tx into this f of x value lambda into e power minus lambda x dx. Next, being one of the limit case in this integration is infinity, then the integrand exponential function must be termed in powers of negative value. So whenever we have any one value or at least one value infinity, positive infinity, and if the integrand is exponential function, then it is always advisable, suggestible to convert the power function into negative value. But that is why I have written here exponential of e power minus lambda minus t into x. So combining these two functions and take minus symbol outside, and the resultant value is e to the power minus of lambda minus t into x into dx. So integrating this exponential function, we can get e power minus lambda minus t into x, and differentiating the inner term and put the result in the denominator and substituting the limiting value 0 to infinity, then we can get lambda divided by minus of lambda minus t into e power minus infinity minus e power minus 0. E power minus infinity is 0 minus e power 0 is 1. So 0 minus 1, that is minus 1. This term gives us minus 1. That minus 1 into this minus, we can get total positive term for this case. But therefore this term becomes positive case. Therefore the moment generating function of exponential distribution is mx of t equal to lambda divided by lambda minus t, where lambda greater than t. Lambda should greater than, that is one condition. Then only this fractional term exists. Otherwise it goes to infinity like that. Denominator may have 0. Next, we shall see how to find out mean and variance of exponential distribution. As usual, we know that the moment generating function of exponential distribution is lambda divided by lambda minus t. That is mx of t equal to lambda divided by lambda minus t here. Now divide numerator and denominator. Divide this numerator and denominator by lambda, then lambda by lambda becomes 1. And if you divide this entire term by lambda, first term 1 and the next term t divided by lambda. That is what the adjustment we have made here. So 1 divided by 1 minus t by lambda. Now you take this denominator to numerator, then we can have 1 minus t by lambda to the power minus 1. So this term can be expanded as a power function, power series, using the formula 1 minus x to the power minus 1. What is 1 minus x to the power minus 1? 1 plus x squared plus x cube plus etc. Next c, that is the term. In place of x we have t by lambda, therefore 1 plus t by lambda plus t squared divided by lambda squared plus t cube divided by lambda cube plus etc. plus any rth term t power r divided by lambda power r plus etc. Now this entire series can be condensed to single term using summation operation. But therefore this can be written as sigma r equal to 0 to infinity t divided by lambda to the power r. If you substitute r equal to 0 here, we can get first term. And if you substitute and if we substitute r equal to 1 here, then we can get t by lambda. For r equal to 2, t square divided by lambda square, and so on. But therefore moment generating function in terms of t by lambda is summation r equal to 0 to infinity t by lambda to the power r. And by basic definition, mu1 dash can be taken from power function, power expansion of moment generating function as substituting r equal to 1, substituting r equal to 2 by taking coefficients of term by term. Therefore mean mu1 dash is nothing but coefficient of t power 1 divided by 1 factorial in this expansion. So t divided by t power 1 divided by 1 factorial is the term here. So t divided by 1 factorial you take outside, the remaining term is 1 divided by lambda. So coefficient of t power 1 divided by 1 factorial is 1 divided by lambda. This is nothing but first non-central moment or mean value for exponential distribution. Next, to find out variance values of exponential distribution, you have to find out second non-central moment, that is mu2 dash. How to find out mu2 dash? In the MGF expansion, mu2 dash is nothing but coefficient of t square divided by 2 factorial. So t square term where you see here, t square term, and 2 factorial is not there. So simply multiply the numerator with 2 factorial and divide this numerator 2 factorial. Then you take this t square divided by 2 factorial outside. But therefore 2 factorial divided by lambda square is the term, is coefficient of t square divided by 2 factorial. This 2 factorial value is nothing but 2 itself. Therefore coefficient of t square divided by 2 factorial is nothing but 2 divided by lambda square. Now simply substitute this mu2 dash and mu1 dash in variance formula. What is formula for variance? Mu2 equal to mu2 dash minus mu1 dash the whole square. Mu2 dash is 2 divided by lambda square and mu1 dash is 1 divided by lambda. Therefore 2 divided by lambda square minus 1 divided by, this is 1 divided by lambda square, one typographical error. This is 1 divided by lambda square, you note this. This is 1 divided by lambda square. When I send you the material, then I will correct it. So 2 divided by lambda square minus 1 divided by lambda square equal to 1 divided by lambda square. Therefore variance is 1 divided by lambda square for exponential distribution. If you take square root function for variance value, we can get standard deviation. Therefore, standard deviation of exponential distribution is nothing but square root of 1 divided by lambda square. That is nothing but 1 divided by lambda. Therefore, SD sigma equal to 1 divided by lambda for exponential distribution.